So this video is designed to help students and parents understand how to solve algebraic equations and how to justify the reasoning, which is part of the Common Core State Standards in algebra. So as we look at this equation, we've got 2x minus 5 equals 3. What I'm going to do is on the left-hand side of this T-chart, I'm going to show all my steps algebraically. This is what we require in math. But sometimes we practice that skill of justification. So I'm also going to do that, so this video will be a double blessing for you guys if you're watching it. So over here I'll write down why I did what I did. That's called justification. So the first step I'm going to do with this subtraction problem is I'm going to change it to addition. So it's going to look like 2x plus negative 5 equals 3. And so for justification, I'm going to write change to addition. That's the step I chose. So the next step is I want to solve for x, and I'm working backwards to solve for x. I have an unknown number times 2 added to negative 5, and the whole thing equals 3. So if you remember when we evaluated expressions, we used a thing called PEMDAS. It helps us remember the order that we evaluate expressions with more than one operation. So when we're working backwards, it makes sense that we would work PEMDAS backwards. I call it SADMA. So when we're using PEMDAS, I would multiply and then add, but since we're working backwards, I want to get rid of or undo the addition first, and then undo the multiplication. So what I'm going to do here is I'm going to add 5 to the negative 5, and that'll get rid of it. 5 negatives and 5 positives make 5 zero pairs that just disappear and cancel each other out. And remember, the rule is if I do something to one side of the equation, I must do the exact same thing to the other side to maintain equality. So I'm going to add 5 to this side. So that gives me on the right-hand side 8. I don't need to write anything here because those disappeared. And then I have 2x right here. Notice that when I show my work, it's all straight down in what we call vertical form, so it's easy to read in the language of math. My justification for this, what I did was I added 5 to both sides. Okay? Now, in my next step, I've only got one more operation to undo. And the way you undo multiplication is by division. So to undo a times by 2, I'm going to divide by 2. And the way I show that is I make it look like a fraction bar. Fraction bar means divide. So 2 divided by 2 gives me 1. And that's what I'm doing when I'm isolating the variable. I started isolating the variable up here by getting rid of the negative 5 so the variables were by themselves. But now I've got 2 variables, and I only want the value of 1x. So I isolate it further by dividing it by 2. Remember the rule though, if I divide one side by 2, I've got to divide the other side by 2. So over here I'm going to write that down. Divide both sides by 2. Now I get down to x here. This is a fancy form of 1. 2 divided by 2 is just 1. 1x, or 1 times x is just x. 8 divided by 2 is 4. So my answer is x equals 4. So I write solution x equals 4. Now, of course, when we solve any problem in algebra, we always check our work. So sometimes I have students write CK for check, just so we know that it's the check part. And I don't have room on this board to show the whole thing, but on a piece of paper, you would just do it underneath it. So to check it, I write the original problem. And I'm going to go ahead and write it as an addition problem here. And then what I'm going to do is I'm going to plug in the value that I think is true for x. So where I see x, I'm going to put a 4. So I'd write that as 2 times 4. And I can use a parentheses to signify multiplication, or I can use a raised dot. I don't want to use an x for multiplication anymore because we have an x for a variable. And then I'm going to put plus negative 5 equals 3. Now if I'm justifying, I want to say why I did that step. And my step, what I did there was I substituted. I substituted 4 for x. And that's important. If there's more than one x in the problem, you got to put 4 in for every x, but in this case there's only one. So then I go through and I evaluate this work to see if both sides of the equal sign are true. If they're equal in value, then this would be a true statement. And to do that, I'm going to use PEMDAS. I'm going to do multiplication before I do addition. So I like to signify which one I'm doing by the little bracket thingy there. And that's going to be 2 times 4 is 8, plus -5 equals 3. And after that, I'm going to add. And 8 plus -5 is going to be 3. And that equals 3. So what I do for justification over here is I say simplify. And I might simplify for more than one step depending on the equation. But in this one it only had a couple steps. And then at the very last step, what I'm doing is I'm asking myself, are both sides equal? If both sides are equal, then I found the value for x that I was looking for to make this a true statement. If they're not equal at the end, then I made a false statement and I found the wrong value for x. There's only one value for x that'll make it true, and that's the solution I'm looking for.